Thanks, Clive. Yeah, and thanks for the opportunity. Yeah, just to add a little bit something which is a slightly different approach to the conventional open loop geothermal that has obviously been talked about in the previous session. So our approach is very much what we call a closed loop system, meaning it is totally closed. We don't go into a formation. We don't look for our subsurface aquifers and water systems. We effectively drill to heat. The geological formation around the world globally is roughly around 30 degrees a kilometre of depth, meaning that for every 30 degrees you drill, theoretically it increases by 30 degrees at least per kilometre. So we have effectively taken an oil and gas approach to this process. We have the systems deployed. We've got sites that are currently now operating. We started by retrofitting existing oil and gas wells with this system to produce heat directly, which we've done. But we now have projects we're actually starting in for power generation as well, which are taking wells down to 200, 230 degrees Celsius, in some cases at 2 or 3 kilometers deep. And we're actually working with power generation. Advantages are that you don't have to do that exploration part at the front end. You drill to effectively a known depth and configure a design of a well to that known depth, specifically to reach a temperature that you want to achieve at the surface. So effectively you don't skip phase 1 and 2, but you significantly reduce phase 1 and 2 in that initial process by looking at this approach and get more into the deliver and operate side quicker. Next slide. So again, we try to look for off-grid solutions for our clients. We've done a number of hospital reviews recently, and most of these are looking at being off-grid solutions. We also work with lots of other infrastructure, from university campuses to business parks to MOD, all types of different infrastructure. But primarily here, we're focusing primarily on heat, and then looking at building in some sort of resilience for parasitic load of any operating systems that we might induce. So by adding heat pumps, by adding things like that to the system, you're obviously creating what they call a parasitic load, which has to be taken off your original load or your operating load. What we do is try to cover that in the design, meaning that the system is completely standalone off-grid. The kilowatt price you get at the end is the price you pay all the time for the duration of a 40-year agreement or whatever's put in place. Next. Despite some of the sort of the general consensus in the UK or globally even, I mean, the BGS represents roughly about 113 locations in the UK that potentially could be used for what they call open loop geothermal. We reckon it's every single location using a monobore closed loop system. So there is no restriction where you can use a monobore system. The other thing is obviously because it's monobore, it's single, it's not double loops. You can put multiples in and create multiple uses of energy in a smaller footprint. You haven't got to have a wide footprint to do that. Next slide. So this is just an example we did for a local hospital that we've done a study for recently, and when we first talked to them back in 2021, they were looking at increases sort of annually going up. Basically to 2030 increase in exponent, little by little. They hit the 2030 targets in 2022. Hence coming back to us for looking for a solution for energy. Next slide. So what we did is we've done a proposal for them, looked at the changing their heat and reducing their costs. We've done the study. We've actually submitted the study, and we've presented them with 2 basic options. One is that we fully fund the system from scratch, and we deliver the energy on a sort of take or pay agreement type structure, with a possibility of, after we've retained or recovered our value proposition or investment, we can then transfer that over to what we call a BOT, like a build, operate, transfer model, back to the hospital or back to the local community type system where they have the opportunity to operate it. So again, trying to do something which adds to local content, local ESG value. The second option is obviously the pay for it upfront type option. With the first option, obviously we take the risk, we take the development risk fully, and we deliver the system, to the end user for a agreed fee of energy offtake for the duration of the power purchase or heat purchase agreement, whatever that is. or both in some cases. Next slide. So the other approach with ours is very modular. So we're working with lots of different types of business cases. Some are new builds, some are old builds, some are retrofits, some are both. And what we have to do is look at what can we modularize. So we're doing some projects where we can modularize the front end, scale up, and then scale down as the project goes forward over a number of years. Meaning that we cater for what's going on as we build it. Next slide. And then basically, the idea again is trying to reach into a bit of technology with a bit of proven knowledge base as well to enable various access to funding routes, which is what we've been quite good at through CeraPhi over our sort of 3 or 4 years of development, accessing various types of funding from green bonds to various types of local and overseas funding for different projects. But again, it's all about really the business case, ensuring that the business model is solid and making sure that we address them risk elements at the front end for the end user and customer.